Hello everyone. In today's video, I will explain stateful sets in the simplest way possible. And by the end of the video, we'll understand why deployments are not suitable for databases and how stateful sets will solve this problem. So let's get started. So why stateful applications are needed? Imagine we have an SQL database which is running inside a Kubernetes and suddenly the pod crashes. Now Kubernetes will create a new pod. But what happens to the database data of the MySQL? Will it survive? Does a new pod get the same identity? So we will go ahead and discuss this. Applications like web servers are stateless. If a pod dies, Kubernetes creates new one and everything will work fine. But when we have databases like MySQL, MongoDB, these applications would need persistent data. They would require a stable network identity, a predictable startup order. Without this, the application will lose data and it will fail to communicate properly as well. So, a question for you right now. Would you run your production database using a deployment or with a stateful set? Let me know in the comments. What is a stateful set? Let's understand that now. Stateful set is a workload resource in Kubernetes. It is specifically designed for stateful applications as the name itself suggests. Deployment is different. Stateful sets is different. Unlike deployment, stateful set will provide stable pod identity, stable network identity, a good persistent storage. There would be ordered deployment and scaling. So you can think a stateful set as deployment's smarter cousin designed particularly for databases. We'll understand its key features. Each pod gets a predictable name. Instead of random pod names, you will see names like MySQL 0, MySQL 1, MySQL 2, and this identity will remain consistent even after restarts. Let's see the naming example as we discussed. Now imagine one crashes. So Kubernetes recreates it. Pod comes back as MySQL1 again, not random MySQL 123. So this consistency is critical for clustered databases. We'll see the differences how we can compare deployment and stateful set. Deployment best for stateless applications, random pod names, shared behavior, and for easy scaling. And stateful set best for databases, unique pod identities, persistent storage, and ordered deployment. Simple rule: web application is equal to deployment and databases is equal to stateful set. Real world examples: MySQL, PostgreSQL, MongoDB, Kafka, Cassandra, Elasticsearch. Headless service. Now there is something that's confusing many Kubernetes beginners, especially me in the beginning. Like, what is a headless service? So stateful sets typically uses a headless service, and it's used in stateful set because a headless service is created using cluster IP none. So instead of giving a single cluster IP, Kubernetes creates DNS records for every pod. DNS records like MySQL 0 dot MySQL dash service likewise. So this allows application to communicate directly with the specific pods, and this is called as the headless service. Now let's see a YAML file how we create a stateful set. Notice these are important fields. The kind has to be stateful sets. The service name, whatever you're using, MySQL, Kafka, MongoDB. Replicas, how many is required? 3, 5. This tells Kubernetes to create 3 unique identifiable MySQL pods using this YAML file. Don't worry if YAML looks little overwhelming right now. The goal is to understand the concept first. We'll look at the persistent storage. This probably is the most important feature. Each pod gets its own persistent volume claim, PVC. If you are want to know more about PVC, you can go ahead and see my early videos with PV and PVC, so you can understand this concept in a better way. So for example, my SQLO is PVC 0, my SQL 1 is PVC1 likewise. So even if a pod is deleted, the data will remain safe. So before going forward operation, I'll like to share a real world example with PVC. Think of it like a database instance having its own dedicated hard drive. Let's see now what is ordered operations. Stateful sets follows strict ordering rules. So when you are scaling up, MySQL dash 0 will start first, then MySQL dash 1 and so on. When scaling down, MySQL 2 gets removed, then MySQL 1, then MySQL 0, like in the descending order. So this predictable behavior is essential for clustered operation. Now, how to verify stateful set whether it is created or not. So earlier we used the YAML file to create the stateful set. So we have two commands to verify now whether it has been created. kubectl gets stateful sets and kubectl gets pod. So to see the pods and to verify the stateful sets, we use these two commands. And you will also notice how the pod will remain. Pod names will be constant in this. We'll quickly wrap up with few of the interview questions around this. If you're interviewing with Kubernetes in your CV, then these questions can be expected in the rounds. So why do we use stateful set? What is the difference between the deployment and stateful set? What is a headless service? How do stateful sets need persistent volumes? Why do they need them? And give some real life examples of stateful sets. Or you can have one simple question: what do you know about stateful sets? Have you ever used it? So you can tell all this in your interview with the understanding, and also when you have worked in real world examples, you can answer them as well. So best practices is we are using it for stateful workloads, ensuring proper storage provisioning, headless service, monitoring storage utilization, and regularly backing up our data. Mm, let's quickly recap. We learned stateful sets are, why database need them, what are stable identities, persistent storage, headless service, order scaling and deployment. In this video, um, we have learned about the real world examples. So if it was helpful, please hit the like button, comment, share and subscribe to the channel. Also tell me in your comments which database are you currently running in Kubernetes. And in the next video we will explore more of Kubernetes jobs and cron jobs, where we'll learn how run one time and schedule task in Kubernetes. So I'll see you in the next episode. Happy learning.